Okay, the following is a video over 10.4 notes. In 10.4 notes is about something called inscribed angles. And the big thing that I want to show you is that, we talked about the arc measure of A to C around the center of the circle, which is point B. But when I'm talking about an inscribed angle, I'm talking about angles that are created from an arc, but whose vertex of that angle is not the center of the circle. So angle D would be an inscribed angle, angle E would be an inscribed angle, and angle F would be an inscribed angle. And there is a relationship between D, E, and F and the angle B. So the first thing I want to do is let's just go ahead and calculate what those angles are. I'm going to use some Geometer's Sketchpad software to do this. And what I want to do is I'm just going to select A, B, and C and measure that angle. And we get that angle is 70.15 degrees. So this angle here is 70.15. And so then we know that the arc measure of AC is 70.15 as well. Now, the interesting thing is that if I look at angle D, I notice that it has the same arc measure as angle B, okay? But it's not, the angle measure is not in the center. It's on the outside of the circle. So let's see what angle D gives us. Now, I'm thinking that it's going to give me 70.15, but it looks a little bit smaller than angle B, but let's just go ahead and measure it and see what we get. Oh, wow, I get 35.08, okay? Let's see what we get if we measure angle E. So angle E over here, let's see what that is. And we get, oh my gosh, 35.08. That's the same thing. D and E are congruent. Huh. Well, I wonder what angle F is. Well, let's see. So if I select A, F, C, and measure that angle, oh my goodness. I get 35.08. That's pretty nuts. Okay, now, well, wait a minute. This number is half the length of this number. So all of these angles here are half the size of angle B. That is pretty interesting. Okay, so let's go back. Let's identify this, okay? So we found that angle B was 70.15 degrees, okay, based on what we had. All right. And then I found that angle D had, what was that, 35.08 degrees. Okay, so this is 35.08 degrees. All right, we found that angle E also had 35.08 degrees. So this was 35.08 degrees. All right, and then angle F we found to also be 35.08 degrees. So this is 35.08 degrees. Wow. So in this angle here was 70.15. All right, so 70.15 degrees. So here's what I'm noticing here. Okay, if I have an inscribed angle, all right, who also connects to this arc measure here, I can find the measure of this angle if I know what this angle is here, and vice versa. So I can kind of write a formula here. All right, so what I want to say is that if I have, and let's just look at angle, it doesn't matter which one of these we choose, but I'm just going to go with angle D. So I'm going to say that angle D is equal to me taking 1/2 of angle ACB, okay? And really what you should write here instead of angle measure ACB is that angle D is equal to 1/2 of the measure of the arc from A to C. All right, and that's kind of the idea here with these inscribed angles. Now, if they connect to the same arc length, then all of these inscribed angles can be congruent. Okay, congruent if they connect to a common arc. Okay, common arc. All right, so that's kind of information I want you to write down. So this is the idea that I want you to see. But the main thing that I want you to see is that not only are these congruent if they connect to a common arc, but they are half the angle measure of these inscribed angles is half of what we see here. Okay. So now let's apply this and answer some questions. Let's take a look at numbers 1 and 2 on your notes. In number 1, it wants us to find the measure. Let me change colors. The measure of arc length, or I'm sorry, of the arc xy, not the length, just the measure of the arc, okay, in degrees. Now I know that angle z, so angle z is 23 degrees, and I know that angle z is half the length of the measure of arc xy, okay? So if I substitute in 23 for z, then I could easily solve for the measure of arc xy. So the measure of arc xy. Now, if I'm just dividing by 2 or multiplying by 1/2, I want to multiply by 2 on both sides. Okay, so I end up getting that 46 degrees is equal to the measure of arc xy. Okay, so that is, we want to use that formula we just had, but I'm just going to write over here that this is 46 degrees. Okay, now we want to go the opposite way, and we want to find the measure of angle R. Let me change the colors. So I'm going to put this as x degrees. Okay, I don't know what that is, and I know it's half the length of this arc measure here. Okay, so I know that the arc of QS, the measure of arc QS, is equal to, now I have this arc length, or arc measure, which is 140 degrees, and I have this arc measure, which is 120. I know the whole thing is 360. So if I take 360 and subtract off 120 and subtract off 140, I end up getting that the measure of arc QS is equal to 100 degrees. All right, so I know that this is 100 degrees. All right. I also know that angle R is equal to 1/2 times the measure of arc QS. Okay, so arc QS I know is 100, so angle R in this case is equal to 1/2 times 100, and half of 100 is 50 degrees. So angle R is equal to 50 degrees. Okay, so this is, you could say x is, yeah, I didn't use x is 50 degrees, so angle R is 50 degrees, but that's what I wanted to, that's the answer. Okay, so let's take a look at the other ones. Now these ones are a little bit more confusing. Okay, I'm just going to do problems 3 and 4. I'm not going to do 5 and 6. I'll let you guys do those on your own. But I want to show you, it wants us to find angle N. It wants us to find this angle right here. Okay, now what I know is that this angle is half the length of this arc. Now I don't know any information about this arc, but I do know that I have this other inscribed angle here that also shares the same arc. So if they share the same arc, remember that these two angles are congruent, okay, because they share the same arc. So what I can do if I'm trying to find angle N, then I know if these two are congruent, I can just set up an equation and say 3y plus 8 is equal to 6y minus 1. Okay, and I can solve for x. So if I subtract 3y from both sides, I end up getting 8 is equal to 3y minus 1. Add 1 to both sides, and I end up getting that 9 is equal to 3y. All right, I divide by 3 to solve for y, and I get that y is equal to 3. Okay, and if I'm trying to find angle N, okay, I want to plug it in. I want to plug y into this right here. All right, so I'm going to take angle N is equal to 3 times 3 plus 8, which gives me 9 plus 8, which gives me 17. Okay, and that's in degrees, so that's what that angle measure is for N. All right, now I can I can do the exact same thing over here with number 4. Okay, with number 4, I want to find angle L. I want to find this length here. Now, what I know is that angle L is an inscribed angle to the arc MN. Okay, and so is angle P. Angle P shares that same arc, so I know that these two angles are also congruent. So I can set 6x plus, equal to, 6x equal to 5x plus 9. And if I subtract 5x from both sides, then I end up getting that x is equal to 9. Okay? And so what I want to do here is actually find what angle L is. So I know that I can take 5 times x, which is 9, plus 9, which gives me 45 plus 9, which gives me 54 degrees. Okay, so you would do the same process for 5 and 6. I'm not going to go over those. I'll let you do those. And this is just part 1 of the notes. There will be videos for part 2. So thank you.